Okay, this is part 2 of section 7.4. Now we're talking about even and odd trig functions. Before we get to the trig function, let's just talk about what an even and odd function is. Now this is what an even function will look like. It's going to be symmetric about the y-axis, meaning, okay, here's my y-axis right here in the middle. This side over here looks like the mirror image of this side over here. Okay, so they are symmetrical about the y-axis. Now notice here that you got 2, 4, and then you've got negative 2, 4. Notice that you have the exact same x value, but different signs. Okay, your y values, though, are the same value and the same signs. Your odd function, it's not symmetric about the y-axis. Now look at these points right here. Okay, for your x-axis, they're the same value but different signs, as well as your y values. They are the same value. They're both 1, but they have different signs. That's a characteristic of an odd function. Okay, and I say that right here as well. They have the same number but different signs for x. For the y values in an even function, your y values are going to have the same number and the same side. Okay, so we said that the graph is symmetrical about the y-axis. So along that curve, your function right here, we call it a curve or a function. Along that curve or function, any 2 points with opposite x values have the same function value or the same y value. This matches the result of calculation. If we look at 4 squared and this should have parentheses around it. Same thing for here. Say these are x values. Now if I put it into this function right here, that's why they're being squared. 4 squared would be 16. Negative 4 squared will also be 16. So I have 2 different x values. They're the same number but different signs, but they give me the exact same y value of 16. You can do the same thing with 5 squared, which is 25, negative 5 squared, which is also 25. So if those were x values, the 5 and negative 5, same number, different sign, they both gave me the same y value of 25. So f of x equal to x squared, a parabola, x squared is a parabola, that's an even function. Because a function such that 2 inputs, which your inputs are your x values, that are opposite, like 4 and negative 4 or 5 and negative 5, have the same output or y value. For the 4, they were both 16. For the 5, they were both 25. So it boils down to this right here. Notice you've got an x and an x. One of them is negative, one of them is positive. But notice both of the f of x values are positive. Okay, you don't write positive, you just kind of leave it out. Okay, so that means that it returned the same y value. Because remember, f of x is just a really fancy way of writing y. Now if we look at the odd function, so the odd function has the same number but different sign for the x value as well as the y values. And we said that it is not symmetrical about the y-axis. Along the graph, or the curve here, any 2 points with the opposite x value also have the opposite y values. So if we look at f of x is equal to x cubed, that's going to be an odd function. That's what this curve is. This is f of x x raised to 3, or x cubed. Now notice here, okay, I have an x here, one's negative, one's positive. But now look at my f of x. One is positive, one is now negative. Okay? So that's the difference between your even and odd functions. Now if you look at your trig function, this is super easy to remember with the trig functions. There's only 2 trig functions that are going to be even. The rest of them are going to be odd. Okay, so cosine and secant, those are the only two that are even. So if you remember that cosine and secant, or cosine and its reciprocal secant, they're even, and say, okay, the rest of them are going to be odd. Now what that means in trig, so even is f of negative x is equal to f of x. Okay, well, here's my f of negative x. I've got a negative right here. Now notice I don't have a negative over here. So with an even trig function, it's like these negatives inside the parentheses, they just go away. Okay? Whereas an odd function, let me write it. Actually, it's right here. Now, if you have a negative inside, the negative is pulled out to the front. That's an odd function. Now notice all of these right here, you've got a negative inside, and what you do to get rid of the negative inside is pull that negative out to the very front. That's what you're going to do with all your odd trig functions. So even trig functions, that negative inside the parentheses just goes away. If it's an odd trig function, that negative inside the parentheses will be pulled out to the front. Okay, here's your fundamental identities. Tangent is equal to sine over cosine. Secant, which is the reciprocal of cosine, will be 1 over cosine. This is the definition of reciprocals. Secant, which is the reciprocal of sine, will be 1 over sine. And cotangent, which is the reciprocal of tangent, all you got to do is take this right here and flip it so it is cosine over sine. Okay, now if we have, they say that sine of 45 is square root of 2 over 2, and cosine of 45 is the same thing, square root of 2 over 2. We need to find out what tangent of 45 is. Well, we know that tangent is going to be, it's back here, sine over cosine. So we got sine of 45 over cosine of 45. Well, they give us sine of 45 is the square root of 2 over 2. And cosine of 45 is also the square root of 2 over 2. Now I have a fraction divided by a fraction. What I need to do is take the top fraction and leave it alone, change division to multiplication, and flip that bottom fraction. Notice these will cancel out as well as this, and I'm left with 1. So tangent of 45 is equal to 1, and that's your final answer on that. Okay, given that sine is 5 pi over 6 is 1/2, cosine of 5 pi over 6 is negative square root of 3 over 2, we need to evaluate secant of 5 pi over 6. Okay, well, we know that secant of 5 pi over 6 is the same thing as 1 over cosine of 5 pi over 6. That goes back to this right here. So we're looking at that one. Secant is 1 over cosine. Okay, so I can write 1 over negative square root of 3 over 2, which I take the top one and don't mess with it, change division to multiplication, and flip that bottom one. And that's your answer right there, because 1 times negative square root of 2 over square root of 3 is just itself. Oh, actually, no, that's not your answer. Because we have a radical in the bottom, we've got to rationalize that. So negative 2 square root of 3 over 3. That will be your final answer for secant of 5 pi over 6. Now you don't have to go through this. If you notice that, okay, I'm looking for secant of 5 pi over 6 and they've given me cosine of 5 pi over 6, you don't have to write all of this down right here. All you have to do is take that number and then just flip it and rationalize where you need to. So negative 2 over square root of 3, okay, we'll rationalize that. Negative 2 square root of 3 over 3, and you're done. Okay, last but not least, we need to be able to evaluate trig functions with a calculator. Okay, now your calculator is going to have sine, cosine, and tangent, but it won't have the reciprocal of these. So if we're trying to evaluate cosecant of 5 pi over 7, number one, I have to be in radians because I have a pi. So make sure you're in radians first. And then second, I don't have cosecant on my calculator, but I do have sine. So if I do 1 over sine of 5 pi over 6, that's going to give me cosecant. Now what you should get is roughly 1.279. And I say roughly because I've not listed all the numbers. I've cut it off after 9. Cosecant of 1.85. Now notice I don't have a degree symbol here, so again I need to be in radians. Now I do have cosine, so all I have to do is make sure my mode is in radians, and then hit 1.85 and then cosine, or cosine and then 1.85 depending on the calculator. But you should get negative 0.2756. Cotangent, the same thing. We don't have cotangent, but we do have tangent. And again, I don't have a degree symbol here, so that's got to be in radians. So I'm going to do 1 over tangent of that same number, which will give me cotangent because they're reciprocals of each other. What you should be getting is 0.2552 for cotangent of 1.3209. Last but not least, secant of negative 2.9234. Again, I don't have a degree symbol, so I have got to be in radians. And again, I don't have secant, so I've got to use cosine, or the reciprocal of secant, to evaluate this. So 1 over cosine of that same number, negative 2.9234, you should be getting negative 1.024 on your calculator. Now, if you have any problems with any of these on your calculator and you're just not sure how to get them, then shoot me an email, or we'll set up some kind of meeting to where I can show you how you need to input it on your calculator to make sure you are getting these numbers.